Okay, so now for these examples, we're going to do the same thing, but I'm going to use DESMOS to answer these. So I'm going to actually type these in and use that graph to answer these questions. So the first one says a soccer ball is kicked from the ground level and the function h of x equals negative 16x squared plus 32x represents the height after x seconds. After how many seconds will the ball hit the ground? So I'm going to go ahead and type this in. So I have y equals negative 16x squared plus 32x. And I want to know after how many seconds will the ball hit the ground. So I want to know after initially kicking, when is it going to land again? And remember, that's always on our x-axis. It's going to be our x-intercept, that second one, of when it's going to land. And so if I zoom in on my graph here, I see the ball starts at 0 feet since I'm kicking it from the ground. It goes up, and I see it lands after 2 seconds. So my answer here is going to be 2 seconds. Okay, let's try another one. So this one says a stunt woman jumps from a building 73 feet high and lands on an airbag that is 9 feet tall. Her height above ground, h in feet, can be modeled by h of t equals 73 minus 16t squared, where t is the time in seconds. It says, how many seconds will the stunt woman fall before touching the airbag? Okay, so I'm going to first go ahead and type that equation in. So I have y equals 73 minus 16t squared. And I want to know how many seconds will the stunt woman fall before touching the airbag. So here we need to be a little bit careful. I am told that the airbag is 9 feet tall. So I'm not looking here at the x-axis anymore like we've done for other problems. I need to know when it's going to be at 9 feet, how many seconds. So to do that, you can go ahead and change this into table format by clicking this gear, click the table, and I want to know when it's at 9 on this side because I know my y is height. I see it's at -2, however, I can't have -2 feet. And I see, when is it 9 again? Well, I see it's 9 again at 2 seconds. So this answer is going to be 2 seconds. Next question says, what is the maximum height of the stunt woman? Well, I know that's the vertex. The y value of the vertex is always going to be my maximum. Right now, when I have it zoomed out like this, I can't see the maximum. So I'm going to hit the zoom out button until I can see it. And then you can zoom back in. And I see that maximum height is going to be actually the starting height, and that's at 73 feet. Okay, the height of a diver above the water during a dive can be modeled by h equals -16x squared plus 8x plus 48. So I'm going to go ahead and type that in. So I have y equals -16x squared plus 8x plus 48. Where h is the height in feet and x is the time in seconds. So first I want to know how high is the diving board. So there's a diver and he's jumping off of a diving board. I want to know how high that diving board is. So that's going to be my initial height, which is the y-intercept. So I'm going to go and find the y-intercept. If I zoom in, I can click on it, and I see that that is at 48 feet. You also could be able to tell this from the equation. Your y-intercept, when it's written in standard form like this, is always going to be your c value. Okay, then I want to find the time it takes for the diver to reach the water. So the diver, he jumped off the diving board. I want to know when he's actually going to reach the water. And so basically I want to know how long he is in the air. And so that means I need to go to, let's hit the home button, my x-axis, and that's going to be after 2 seconds. Okay, go ahead and pause the video. I want you to try and do this last one. Okay, so this first one was actually a little bit tricky. You want to find the time it takes the rocket to reach a point 10 meters above the ground. Here, if you do the table, I see that 10 never shows up over here. And if I look at the graph, I see when it's at 10, there's 2 options here. It's right here and right here. And I see that's not crossing an even line. So you can give a guess on here, an estimate. So I can say approximately at 0.8 seconds. And this is a little bit before 6, or a little bit after 5, so I'm going to call that 5.1. Then you want to see how high the firework is after 2 seconds. There you can look at the table. I see 2 here, and that is at 40 feet.